All right, 11.4 inference about two population standard deviations. So just like we've been doing, again, we go through all of our pieces here when we're looking at proportions, means, and standard deviations. All right, so first of all, when we're doing this, we're going to have to look at what we call our F distribution. So we have a new chart with these, and so we have what's called the F distribution. Okay. All right, so requirements for testing claims regarding two population standard deviations. One, the samples are independent, and then the populations from which the samples are drawn are normally distributed. Okay. So if they're not normal, probably shouldn't use this. Okay. Now you're going to see a lot of powers and subscripts. It just means that our powers are for variance, and then our subscripts are for just which population it's from on those pieces. Okay. All right. So to work this by hand, to find our F equals, we're going to be looking at the variance of 1 divided by the variance of 2. For those, okay? And so we can do that by hand. Now, again, a lot of this stuff we are going to do in the calculator, so it's not going to be that big of a deal when we're looking at those pieces. Okay. Now, our F distribution is going to look very similar to our chi distribution, depending on degrees of freedom and all of that. We just have other types of degrees of freedom. Notice there's some n's and some d's. We have a numerator and denominator when we're looking at these pieces. Okay. All right, so here is kind of how they're going to write these. We have the F distribution here of alpha. Now we have to talk about our numerator and our denominator. So it says n minus 1 comma n2 minus 1. So that's our numerator and denominator. And they're going to give you what those are and tell you how to work with those pieces when we're dealing with them. Okay. All right. Now, what if, notice this is always to the right. So if we go back and read here, we're talking about to the right of our critical value. But what if we need to the left? We have this formula. So we have our 1 minus alpha. When I actually calculate that, we do 1 over f of alpha. And then we switch our numerator and denominator. If you pay attention to your subscripts there from one side to the other, we switch their location. So that's going to be important to pay attention to. Okay. So our first one, it says find the F, the critical values here for the F values. It's a right-tailed test, so we know that we're just keeping it as it is. Our alpha is 0.05, then our degrees of freedom in the numerator are 10, and the degrees of freedom in the denominator are 7. So they already tell us what our degrees of freedom are for those. Okay, so we're going to be looking for F of 0.05, comma 10, comma 7. All right, so that tells me the numerator and denominator. Now you're going to have a chart for this with these pieces, and so you're going to see certain things in areas, okay? So we got 2 degrees of freedom. Our first one here is listed on the top. Notice it says numerator. So that's where we're going to pick out our numerator. Well, our numerator was 10, so that's why we have 10 boxed in here. Now over to the other side here, even though they don't write it, this is our denominator. And so we had 7 degrees of freedom here for our denominator. Now within every denominator, you're going to have 5 pieces here to choose from, and it's always going to be one of those, so don't try to overthink that. What if it's something else? It's not. It's going to be one of those pieces. And so for ours, our alpha was 0.05, and so that's why they have that 0.05 boxed in. And so we go from there into the 10, and so we get 3.64. That is our critical value for this F distribution for these pieces. Okay. So a lot of little details there. Again, we got to know our numerator, our denominator, and then our critical value there, level of significance when it comes to those pieces. All right. Now, what if we want to do a two-tailed test? Okay, so find the critical F values. We have a two-tailed test for 0.05 with a numerator of 15 and a denominator of 20. All right, so two-tailed means we're going to be breaking this thing apart. We're going to be looking at alpha over 2 because we have 2 pieces for those. So alpha over 2 is 0.25, and then 1 minus 0.25 is 0.975. Okay, so that remains the same. But because we're doing 2 pieces now, you'll notice that our first one is here. We need to be to the right of that one, and then to the left of this value, okay, for those. All right, so we got to pay attention to those pieces, so let's look at how we do those. All right, so we start here with our first one, our alpha over 2, because that one is direct. It says to the right of that one on those pieces, and so we go and do that one directly as it is. So we would go to our table of values, we would look for a numerator of 15, denominator of 20, and then find the 0.025 on that group when we're looking at that, okay? Now, what about the one to the left? So we have to change some things up there for those. And so they work through those pieces, okay? So we see here that when we talk about to the left of 0.975, 15, and 20, we actually need to change to this formula so we can find it, right? So our 1 stays on top, but notice right here, that's 1 minus, so we still get that 0.025, and then I switched the positions of the 15 and 20 to get my new numerator and denominator. Okay, so when I go to the chart and do that, we get 2.76 and then do 1 divided by that for those pieces. Okay, all right. So those would be our 2 critical values there on those. All right, now if the number of degrees of freedom is not found on your table, we just get the closest thing to it. And so we always kind of do those pieces that way. All right, so let's look at our hypothesis testing so that we can find these for a situation, okay? Now, again, a lot of these things are still the same as what we looked at earlier. We still have our two-tailed and left-tailed. Now, we are comparing one standard deviation to another, so paying attention to those pieces, okay? We still have our test statistic, F, there. And then looking at our graphs, paying attention to my left-tailed, right-tailed, and what do I need to do for those pieces, okay? All right. This one is not robust, so any departures will make the results useless, so make sure we're careful with that, okay? All right, so here they give us some tables. We're looking at Cisco versus General Electric, and so let's look at how we can compare these pieces here, okay? All right, so since they gave us a table, we're going to go in, we're going to put these in to L1 and L2, okay? So this is L1, this is L2. Now, I've already done that, so when I go into Stat and I edit, I've already got those values already in there for us. Now, it's okay that there's not the same number of values. We're looking at standard deviation, so we don't have to worry about that. We're going to be calculating those things here in the calculator, all right? All right. Now, because we said when we go back and read our piece, it wants to know if it is greater. So let's go back here. Does it suggest that Cisco stock is more volatile than General Electric? So more than. So it's going to be a greater than when we deal with those pieces. So let's go ahead into the calculator here and let's look at what we're going to need for this. So we're going to go into Stat and then over to Tests. So Stat over to Test. And then we're going to go down all the way until we find 2-SAMP F test. Now it's a good ways down, so we just take our time, make sure. So sample F test, 2-sample F test. Okay. All right. Now we have data, so we're going to keep data there. We have them in L1 and L2. Our frequency is 1. And so we said here that we think one is bigger than the other. Now, L1, we put in our Cisco. L2, we put in General Electric. And so it says here, Cisco more than General Electric. So that's why I want the more than for those pieces. And then we're going to calculate. Okay? All right. So that gives us a bunch of information. So let's see what we need from it here. So we see that there's an F statistic. They got 7.51. Well, we got that as well for our F value right up here, okay, for those pieces. So we still got our 7.51 or 52. Rounding will be important on those, but it'll be close. Okay, now we got to go in and look at our degrees of freedom with these pieces. Okay, so there were 10 in the first one, 14 in the second one, so our degrees of freedom are 9 and 3 for those. Okay, so our first one's our numerator, and our second one is the denominator on those. Okay, and so if we look at a level of 0.5 significance, we do our F of 0.5 for 9 and 13, and we get 2.8 if we go to our table. Well, when we look at that, we have our 5.1 that is greater than 2.8. So that means we would reject the null hypothesis, okay? Because it's more to the right on those, okay? Now, what about the p-values? So we would compare our p-value to the significance. Now, notice here it says 6.9, but we see that e down there of -4. So we need to move that over 4 places. And so that's where they get this value of p equals 0.0007 on your screen here, because we moved that decimal over here to the left 4 places to get that 0.007. Okay. All right. Now that 0.0007, that is less than our 0.05. And so therefore, we would reject the null hypothesis using that method as well. Okay. All right, so here's another one. Going back to our rats from the last section, we can do the exact same thing here with those and check out the pieces for them. So let's go ahead and do that. Let's clear this out. Let's go to stat number 1, and we're going to put those things in. Now I need to clear that out so I don't make any mistakes. And so let's take a second, put that in. This always just takes a little bit of time, so please bear with me. Right, so I think there were 14, so that was good for that one lined up there. So let's do the other one here. Almost there. And 9.94. Okay. So again, we would go back into stat, we would move over to test, and go all the way down to sample F test. Now this time it says that we were not equal, right? For those pieces. So is it different? So that's a not equals. And we would calculate there on those, okay? And so we can again see, we go through those, it's a not equal, so it's a two-tailed. So we'd be comparing that against our alpha being 0.05 on those. Now you can see we got our F statistic, and it does match what our F statistic is there when we do our rounding. Now, because it is two-tailed, you will have to do both the F of 0.025, so dividing that 0.05 in half, so that you're able to do that piece. And then as well here on the other side for those. Okay, you got two pieces, so anytime you're doing two-tailed, we got to look at both of those ends when we're talking about them, okay? And so we get our values here of 328 and 0.30 is my lower and my upper for those, being left and right of each one of those um, pieces. Okay. Now, when we look at that, we can see that our 1.024 is in between those two numbers, so we do not reject the null hypothesis. Okay, if it was less than the 0.3 or greater than the 3.28, we would reject it. But in this case, it's between them, so we do not reject the null hypothesis. All right, we can also look at the p-value here. And so we look at our p-value, we get 0.966. There's no e at the end, so that's all it is, 0.966. And that is greater than 0.05. So therefore, this would also say we do not reject the null hypothesis. Okay. So again, we can pull all that information right there from the calculator. All right, so those are the things that we're going to need here in 11.4.